right, Haley, here is a little bit about how to use the equation of a line to draw a graph. So we've got the equation given right here. I'm just writing it down on my page before I switch windows. Negative 2 over 3 x plus 1. Okay, so if we look over at my page here, so the slope, hopefully you're pretty familiar with this part. The slope I can pull right out of the equation. It's the number that's in front of x, so it's negative 2 over 3. And then the y-intercept is 1. Okay? So then if I have a graph, or if I'm going to make a graph of that line, like that. Thankfully you have a grid, so you don't need to draw one. 2, 3, 4, negative 1, 2, 3, 4, 2, 4, negative 4. This is my x-axis, this is my y. Okay, so that roughly looks like the grid that you have on your own page. Okay, so the first thing I'm going to do, my y-intercept is 1, so that means on my y-axis, my line is going to have a point right at 1. Okay, so when x is 0, y is 1, right there. Okay, so you can always just plot your y-intercept point first. Okay, so y-intercept 1 right there. And then I'm just going to use my slope to find additional points. Okay, so the slope, I read it as negative 2 over 3. Now, if you put that into your calculator, you're going to get like 0.66667, which is not that helpful of a number. It's actually more useful to read the slope as rise over run. Okay, so I'm going to say my rise is negative 2 and my run is 3. So what that tells me is if I already know one point, I can locate another by going down 2. So that, because that's a rise of negative 2, and then over 3. 1, 2, 3. And that gives me another point on the line. And really, to graph a line, you only need 2 points. So once you've located one other point, you can, ideally you'll use a ruler, but you can draw a line to connect them. Okay? If you want to graph a couple more, maybe those 2 points ended up kind of close together, and you want a few more just so you can be confident when you're drawing, you can just repeat the same step. So down 2 over 3. Now the problem here is that when I go over 3, that takes me over to like 6, which is not a number that is included in my line. I could also, though, use the slope to go backwards if I wanted to. So instead of going down 2 and to the right 3, I could go up 2, and then I could go to the left 3. So then it's kind of like I'm doing the negative as the run part. So up 2 and over 3 brings me to like a point right there. Okay. Now, because my graph is all hand-drawn, these points aren't lining up beautifully. If you're using a proper grid, like the one on your own handout, the points should line up a little more nicely. And then you can just connect them all with a straight edge or a ruler. Okay, so that's how you would do that question. Let's see what else we got here. Okay, so same idea. You're given equations for lines, and you're asked to graph them. So I'll just give you some hints for these. So this middle one, we can do pretty much the same thing that we did before. The only kind of weird thing is that you're going to treat the slope as negative 2 over 1. So your rise would be negative 2 and your run would be 1. Okay, that when you have a whole number for slope, that's how you use that. For this one, slope is pretty obvious. Rise of 3, run of 2. There's no y-intercept given, which means that your y-intercept is 0. So you can have your first point right there, okay, when x and y are both 0, rather than something else along the y-axis. Okay, like here, our y-intercept would be negative 1. So we'd plot that right here once we've got numbers on our scales. But here, our y-intercept, there's nothing written there. It's 0, so I would plot it right there. Excuse me, sorry. Okay, the last one, this is kind of a tricky one because there's no x given at all. It's just y equals 2. That is a special kind of line. It's called a horizontal line. So y equals 2, that means that my y-intercept is 2. It actually means that every point on the line, no matter what x is, y is always 2. So you can just draw a horizontal line. If this was 2 on the y-axis, which I'm assuming once you label your axes it will be, then you can just draw a horizontal line going through y equals 2. Okay, so here we're only given a y-intercept, we don't have a slope, which tells us that the line is perfectly flat. Okay, number 5, it looks like you did a pretty good job on that. So you've got -1, -4, that looks good, and you've got 2, -1, that looks good, and your slope, I would say you're going up 3 and over 3 here. So I think your slope is 3 over 3, which is the same as 1. Okay, but your y-intercept is -3. That's good. So I would say the answer to this, number 5a, I'll flip over to my paper, should be slope equals 3 over 3, which you can simplify to just 1. Y-intercept, you were definitely correct on. It's -3. So then your equation should be y equals 1x minus 3, like that. Okay, so don't forget the x when you're writing the equation of a line. This one, so we've got c at 2, 1. We've got d at -1, 4. Okay, so once again, our slope is -3 over 3, which would be -1, not 0. And then our y-intercept here, rather than being -3, that looks like a +3 to me. Okay, so here you're going to have y equals -1x plus 3. Okay, don't forget the x when you write your equation. So here, y-intercept is 0, nailed it, got it right. The slope here is the number in front of x, so 4 over 5. Okay, and then the y-intercept here, plus 3, got it right. The slope here, there's no number written, just the negative symbol, so the slope is -1. Okay, if there's no number there, then the slope is 1. Or if it's negative, -1. Okay. Oh, that's the end of the questions you sent me. I think that kind of covers things. I feel like I went through the rest of these for you. Okay, so I'll stop it there. I'll send you this video, and then you can let me know if there's anything else I can help with.